Okay, brilliant. Good afternoon, everyone. I hope everyone can hear me. I can't exactly see the chat box, so if you have any questions about DCU or the course that I'm studying, just pop them in at the very end there, and I'll answer them all. So my name is Malha. I'm a final year bioprocessing engineering student here in Dublin City University. I had initially planned to pursue a career in law before putting down any type of science on my CAO. However, during my leaving cert cycle, I was diagnosed with meningitis, so that completely changed my perspective on life and my career goals. So after spending a lot of time in the hospitals and witnessing the impact of medical science firsthand, and it made me realize the importance of innovation in healthcare. So that's how I actually started researching all types of science, and I became deeply inspired by how the scientific advancements could save lives and improve the quality of care for patients like myself. So this entire experience, although it was very traumatic, I wouldn't recommend. It sparked an interest in bioprocessing and producing essential medicines like vaccines, like COVID vaccines, the COVID-19 vaccine, and even sustainable solutions that benefit the society. So the idea of being a part of that kind of field that combines not only science but technology and sustainability to make such a big difference in the world that we're living in really resonated with myself. So in terms with what I'm studying and what is bioprocessing, so that is the use of living organisms or biological systems to create products like medicines, biofuels, sustainable materials. So the role of bioprocessing, it dives into pharmaceuticals there. So as I said before, just producing vaccines, monoclonal antibodies and enzymes. And then in terms of the food industry, we're looking at fermentation process for yogurt, beer and cheese, and then sustainability. And we're producing bioplastics and biofuels to combat climate change. So here in the School of Biotechnology in Dublin City University, we have about 4 different science courses in relation to biotechnology. So we have the bachelor's degree in biotechnology, the bachelor's degree in genetics and cell biology, the biological science general entry, and then the bachelor's degree in bioprocessing. But then we also have the bachelor's degree in analytical science, and then the environmental science and technology. So to get to where I am right now, I completed. Can't see the slides. Hold on a minute. Let me just try that again. Why can't we see the slides? Okay, brilliant. Sorry, I just had to make sure that everyone else can see the slides here. So what was I saying? Right, so to get where I am right now in terms of what I'm studying, so that is bioprocessing engineering, I completed a 1-year degree, which is the biological science general entry, and then from getting my grades in semester 1 and semester 2, I specialised into bioprocessing engineering, but you can also specialise in biotechnology, genetics and cell biology, and lastly bioprocessing. So the course code for the general entry science there is DC180. The CAO points for entry in 2022 was 511, in 2023 was 488. So we're looking at the requirements of an O6 or a H7 in English or Irish, and then we have O3 and a H6 in maths, and an O3 or a H5 in any of the sciences there. So it was 487 in 2024. So if you want to make a note of the course code there, it's just DC180. So just to break down years 2 and 3 and 4, since first year was just a common entry for all type of science students, so we're talking about biotechnology students, genetics and cell biology students, and myself, bioprocessing engineering. So it's just a common entry where we do physics, biology, and chemistry, and then we also have our labs in that, and then we also have our statistics as well. So in year 2 of bioprocessing, once specialised and once majored in, the modules consist of biochemistry, microbiology, genetics, bioprocessing, engineering, chemistry, and mathematics. And then in year 3, we have advanced biology and bioprocessing engineering, bioprocessing and the environment, the problem solving for bioprocessing, pilot scale bioprocessing, and intra, which is integrated training. It's just a work placement here in DCU. And year 4, which is the current year that I'm in, the modules that I'm currently doing are industrial bioprocessing, bioreaction engineering, the biology option, bioprocess automation and control, heat and mass transfer, advanced data analytics, advances in bioprocessing and sustainable bioprocessing, as well as our research project in semester 2 of final year. So this is just a visual flowchart of year 1 down to final year. So as I said, in first year, it's just common modules for all programs. It consists of your biology, your chemistry, and your physics as well. And then you have your labs in that, and then you do statistics alongside that, which is basically just, higher level maths, just higher level Leaving Cert maths. And you don't have to worry about I only did biology for my Leaving Cert, so I didn't pick up chemistry and physics, but everything is taught from a very common level. So and then from there you kind of just build it up as the days go by and as the semester goes by too. In year 2 and year 3, in year 4, as I broke it down earlier, but intra is where it takes place in the second half of the semester of third year, which is just a work placement starting from January, ending in August, and it is a paid opportunity as well. So in terms of intra, you could be working alongside biopharma industries likes of Pfizer, Eli Lilly, MSD, we have Bristol Myers Squibb and Alexion. And those are just the sites there, the images there on the right. So now just to talk about my intra, I completed an 8 months internship in Grainful Lab as a research intern, and that was in the School of Biotechnology in DCU. So during my internship at Grainful Lab, I worked, as I said, as a research intern, and I focused on the production and the purification of lactic acid. And lactic acid is a pursuer for the biodegradable polymer polylactic acid, so PLA. And the project that I was working on aligned with Grainful Lab's mission to convert brewery and distillery waste into sustainable bioplastics for the use of life science laboratories, so the likes of a petri dish and a conical flask, so instead, or disposable pipettes, so instead of single-use plastics, we use PLA, which is a type of plastic that can disintegrate naturally over time, and this actually reduced the reliance on fossil fuel produced plastics. So my work spanned between, I just have some images here of all the work that I conducted during the 8 months placement. Sorry, I've been told that my slides are after disappearing again. What's wrong with this? Okay, so I'm not sure if you can see the images there from the work that I conducted during my internship. Hopefully you can, but so the work that spanned between upstream and downstream bioprocessing. And in the upstream process, I prepared malt rootlets from the brewery waste for the enzymatic hydrolysis, and that produced simple sugars, which were then fermented to produce lactic acid. And so in the downstream process, I optimized the purification techniques. So I focused on particularly the color removal using ion exchange chromatography, and throughout that I analysed biomass growth and glucose consumption and lactic acid production, and this just ensured that there was quality lactic acid produced at all times, and nothing was fluctuating up or down. So I gained a technical expertise in bioprocessing, including the bioreactor operation. Although I worked with, the bioreactor and the likes of like, an assay and pipette tips and all that during my labs from first year down to third year. But in Grainful Lab, the laboratory, I scaled, so everything that I used was just scaled up. So I went from using like a very small bioreactor, which is just a little vessel where all of your microbes are being produced and stirred and everything, so to working with the 15-liter bioreactor. So I used purification processes like liquid extraction, which I've never done before. So not only did I enhance my techniques, but I also worked and was able to learn new techniques from my internship. So I also conducted an ion exchange chromatography, and that just additionally strengthened my data and analytical tools, because with every experiment or every task that I conducted each week, I'd have a data set on Excel, and then I'd have to present it, or I'd have to present this to my employer at the end. So and then at the very end I had a big massive project presented. So with all of these graphs and the methods, I also improved on problem solving and teamwork and communications, because not only was I working with other interns, I was also working with master's students and postdocs, as well as my employer as well. So this entire experience just bridged the gap between my theoretical knowledge that I have gained throughout first year, second year, and third year, and the application process, the practical application. So modules that I had studied in third year, like design and operations of bioreactors and downstream processing, just provided a strong foundation. So before going into my internship, I had known all the, well, not entirely the entire scale, but like, the basic level of the theory. So and then hands-on tasks like running like a 2.5, I think it was a 2.5, a 2.5 Ralph bioreactor, and I also was analyzing HPLC data as well. That just deepened my entire knowledge. So and then where it also helps me work on practical challenges is troubleshooting experiments. So for the lactic acid was fluctuations and data sets were up and down. Like, I developed skills that arised from all the troubleshooting, and I'd just basically just start the task again until I get my desired outcome. So early on, I focused on, I faced unstructured lab time and initial difficulties during my internship with the lactic acid assay, just because if you don't get like a certain amount of lactic acid produced, you just have to make sure you're just starting from scratch. So you're processing your brewery and then milling them and adding the enzymes and all that. So the entire experience just emphasized the safety protocols and cybersecurity training that was all conducted at the very start of the internship, just to make sure that every individual and every intern is safe using all types of hazards and equipments, and just tools like the HPLC tool, which is high performance liquid chromatography. It's just a big technique tool that just separates colors components in the solution. So this entire internship not only prepared me for the bioprocessing field, but also clarified my career goals. So while I enjoyed research, and the exposure has inspired me to actually explore opportunities in the biopharma industry. So if I could actually, with my experience here, because I was so lucky enough to do upstream and downstream, both of the sectors in the 8 month period, I could definitely go into a biopharma industry as a graduate, because I had both the experience there. So that basically concludes my talk. If you have any questions about like my course or any type of modules or what exactly I'm doing in final year, you can just pop them in the chat. Alright, so if there's no one that has any questions, but if you think of any later on, here is the Unibuddy link. I hope everyone can see that and can access it, so you might want to save it somewhere. And if you think of any questions later on, even just like in a couple of weeks or a couple of months time, you can just pop in your questions there. Right, thanks. Thank you everyone.